Hi class, what I want to do in this video here is walk you through a challenge activity in module 8.2, and this has to deal with hypothesis test for the difference between two population proportions. And there's a number of challenge activities in this section, and I'm only going to do one here, and what it'll do is it'll help you solve the rest of them because they all pretty much follow the same. So hopefully after watching this, you'll be able to tackle all the challenge activities in this module. So here's this problem. A state housing department is trying to determine if housing prices in County B are lower than in County A. So look, it tells you it's lower, it's going to be a left-tailed test. The department decides to randomly sample recently sold homes in both counties and determine what proportion sold for more than $250,000. All right, since County A is considerably larger than County B, the housing department chose a larger sample for County A. That's fine. So the results of the data collected are shown below. So you can see here, here's the output for County A, here's the output for County B. It looks like we have a confidence level, a z-score, and a p-value. Okay, so what is the p? So you can see it's right here. It's 0.009, so they want it to 3 decimal places. What is the z? Well, it looks like it's negative z-score, negative 2.346. And then look, it says, well, what is the number of samples in County A? Well, the observations here, that's 900. And what is the county samples or the County B samples? Well, that's the observations here for B of 500. What is the sample proportion for County A? They have it listed right here. And they want it to 3 decimals, so 0.739. And for County B, look here at 0.68, so I'll go 0.680 here, so it's the same to 3 decimal points. And we got it right there. Okay, so that's just grabbing the data from the Excel output. But now let's go and conduct a hypothesis test here, okay? So a manager of a coffee shop is trying to determine if drive-through customers buy fewer, so again, looks like it's going to be a left-tailed test, fewer items than customers who come into the shop. Okay, so the manager randomly samples both populations and calculates the proportion of customers in each that buy 3 or more items. Okay, the results of the data are shown below. Okay, so first it says, what are the population parameters here? So there's a bunch of options here. And what it is the proportion of all customers in each category that buy 3 or more items, okay? And remember, what the manager thinks is that drive-through people buy more, or people who go through the drive-through. Okay, what is the significance level here? So you got to look at the confidence level. Here it's 90%, so that means it's 0.10. So what is the null? Well, it's always a statement of equality. And then what is the alternative? Well, again, it's going to be a left-tailed test because the key here is that it's fewer. Also, just as another way you can see, when the z-score is negative, looking here, it's probably going to be a left-tailed test. And if it's positive, it's probably going to be a right-tailed test. However, it could be a two-tailed test, so that's why you have to, read through it and decide, looking at the keywords here. Should the null be rejected, or does the null fail to be rejected? Well, you look at your p-value, it's greater than your level of significance, so you're going to fail to reject the null. What that means is insufficient evidence when you fail to reject exists to support the claim that drive-through customers buy fewer items than in-shop customers. And we got it. So this video here hopefully set you up for success in module 8.2. At least the challenge activities, and as always, you can reach out to me for any help that you might need.